In many algorithms, you might want to maintain a set of objects of a particular type. Okay, algorithms often need to maintain set of objects that you are type. Okay. So the set data structure allows you to do that. It gives efficient ways to do things like a set data structure implementation gives a way to implement this with efficient operations like union, intersection. Okay, so the SML of NJ library that we saw gives many such implementations. Okay. So let's have a look at its man page. So here you see, for example, if I want to maintain a set of integers, I can do it using the int binary set, int list set. Here the set is maintained as a list of integers. Here it is maintained as a binary tree, and finally int red black set. This is probably the most efficient way of doing it. Okay. So for example, there are multiple implementations for int set given by int binary int list set int list set 3 int red black set. So this is implemented using binary tree, using this and using red. Okay, so this is this you can use from the standard. Now suppose you want to so first of all, what are the operations available? Well, you can have a look at the odd set signature, which tells you that. Okay, the odd set signature gives you on operations are defined. You can have a look at this. Okay. Now suppose you want to define it. So let me just defining your own term. Defining set data structure about your own type. Okay. So for that, you can use one of the generic implementations. So how does this generic implementation work? So there are two steps. First, okay, you define an odd key a structure K of type of signature odd key for your data type. Use this K as parameter to one of the implementation set Okay. So what is this odd key structure? This is something that we have already seen. It's a type, right? And there is a comparison. Odd key star, odd key 2. We call that the order data type. Okay, so you have to define. So suppose your data type is foo. So let's say it's your data type, and you want to define sets of foo. Then you have to define something like structure foo what equal to struct somehow you have to define from that. Okay. Now second, with this ordering you have to use the appropriate functor. Okay. There are 3 functors available. So one is called the list set functor. Okay, so let's have a look at those things. We have this binary set functor, this set functor, red black set functor, splice set functor. All these different implementations are there. Okay. So the set implementations are list set functor. Okay. Binary set functor, etc. Okay. So how will you do it? How will you fix for your type? You will define something like structure foo set equal to, for example, red black set fun. On you have already defined foo odd. Okay, so now you can do foo let x equal to let's say foo. Let's look at what things are given here for sets. For example, you are given the empty set. Okay. Set okay. Define something like this. Okay. Etc. Okay, this is how you use the functors and other facility to define your own set data structure. Okay. Okay. There is also a related data structure called the map data structure. Okay. This is to store a key value finite map from keys to values. Okay. Again, you define an odd key structure for it. It's a structure of odd key signature, and pass it on to the appropriate functor to get an map data structure. So This is captured by int map, int red black map. We'll have this map constructed, which is for where the key is integers. Okay. So I will point you to the documentation. So let's put the documentation here.